Now, absolute values. Absolute values kind of quite often when they're taught by not so great teachers, we're told that an absolute value is just always something positive, which is kind of true, but that's not really what the definition is. The definition of an absolute value equation is it's the distance of a number from zero. So yes, typically if we're dealing with just real numbers in one dimension or two dimensions, we get that it's just going to get positive because it's a positive distance. But if you go into later on mathematics, that absolute value symbol will mean something very different when you're, let's say, dealing with complex numbers or something like that. So really it is that distance from zero. So for the absolute value of 3, yes, it's positive 3 because it's 3 units from 0 on the right side. Negative 2, absolute value gets you positive 2 because it's 2 units of distance away from 0 going to the left. So if I'm solving for the absolute value of p is equal to 3, this question isn't asking me to just take 3 and say it's positive. That'd be a pretty easy question. Instead, it's asking for what numbers are 3 units away from 0. Well, I could either have it go in the negative direction, or I could have it go in the positive direction. And those are my two answers. So if the absolute value of p is equal to 3, that means p could be negative 3, or p could be positive 3. To see it again, if we're solving an absolute value equation, our first step is to get the absolute value by itself. So that's already happening, which is great. And now I'm going to break it into those two possibilities. My one possibility is the negative. My other possibility is the positive. So 4w minus 3 is equal to negative 5, and 4w minus 3 is equal to positive 5. All I've done is flip the right side of the equation sign. And then I just go about solving it as though it's a regular equation. So the left side, I would add 3 to both sides, divide by 4, and then reduce. I get w is equal to negative 1/2. Right equation, I add 3 to both sides, divide by 4, I get w is equal to 2. And if I want to check my answer, not super difficult, I plug it back into the original equation and both of my answers should work. See another example. This is what I'm talking about when I'm saying it's not always going to be the case that you'll have the absolute value by itself immediately. So in this case, I don't have the 2x by itself. So my first step, before I flip anything, is to subtract the 3 over. Now that's very important. If your absolute value is not by itself, your first step is to isolate it. And now, once it is by itself, I can split it into my two possibilities. I get 2x is equal to negative 6, and 2x is equal to positive 6. Now I divide both sides by 2 on the left side, I get x is equal to negative 3. I divide both sides by 2 on the right side, I get x is equal to 3. One more equation, and then I'm probably going to move into inequalities if I remember correctly. Same step. First step, subtract 3 from both sides. Now, I'm not going to kind of fall into the trap of following the process mindlessly and saying, okay, anytime I have the absolute value by itself, I just go ahead and flip sides and I don't really have to think about what I'm doing. If you see a negative on one side of the equation after you have the absolute value by itself, I want you to pause and think about what absolute value means. It doesn't mean always positive. It means the distance from 0. So if you get an equation that has an absolute value is equal to a negative value, well, you can't have a negative distance. So you don't go through the problem-solving process any further. You stop immediately here and say, well, I can't have a negative distance. No solution. Moving on to solving absolute value inequalities. So there's really two types, so put them in quotes there, of inequality or absolute value inequalities. You're either going to have the absolute value less than a number once you've solved, or the absolute value greater than the number. And we call this the inside case. We'll see shortly why we call it the inside case. So this is the less than. We have our absolute value less than something. So in this case, I actually have to do no solving. I don't have to get my absolute value by itself. It's already done that way. So instead, I'm going to break it up into my two possibilities. I have a positive number on the right, so I don't have to be concerned about that negative case. My first possibility is going to be, I'm not going to change anything. Remove my absolute value and say x is less than or equal to 4. Nothing changes. When I flip the sign, though, when I was solving equations, my second equation, I would flip the sign. In this case, I have to flip the sign of the number, so I'll get a -4, and I have to swap the sign of the inequality. So my second inequality that I get is going to be x is greater than or equal to -4. So remember that. If you're dealing with your first one, you just bring down the inequality, we don't change it. Your second inequality, you bring it down, and you have to flip the number and flip the sign. Flip, flip. Now, if I'm going to graph this equation on a number line, I'm going to have at least -4, 0, and 4. If you were kind of on top of your game, it would be better, yes, to do the numbers in between 0 and 4, but bare minimum, this is all I would ask for. And so if I'm going to graph it, I'm going to graph everything bigger than 4, and it's bigger than or equal to -4, so I have a dot there. I'll do everything less than or equal to 4, so I will have a dot there as well. And if I'm going and graphing those directions, those arrows kind of run into each other at each of the closed dots, and so that's going to actually be my graph. And so if I write that in interval notation, well, it's everything between -4 and 4, so my smallest possible number is -4, my biggest possible number is 4, and yes, they are brackets because it is less than or equal to and greater than or equal to. Hopefully you're seeing why I called type 1 inside. Well, the graph was inside the two numbers. The interval notation was inside the two numbers. Now, let's try and do it again. Let's solve for the absolute value, get the absolute value by itself before we start to split things. Don't get ahead of ourselves by just falling into the process. So I'm going to subtract 3 from both sides. I'm going to divide 2 from both sides, and now I have my absolute value is less than or equal to -1. Now, hopefully some alarms are going off in your head, and you should be thinking, uh-oh, I have my absolute value, I have a negative number on the other side. That means I have to be careful about this. I don't fall into the process immediately. I have to think about what this means. So if we think about what this means, well, again, absolute value is distance from 0. So what this question is really asking, the English behind this question is saying, okay, what number has a distance from 0 that is less than or equal to a negative number? It's nothing. There's no number that meets that requirement. So again, no solution. Type 2 of absolute value inequalities are the outside form. So in this case, I have absolute value of x is greater than some number, a. So let's see that in practice. Here I have a fairly lengthy inequality. So my first step is to isolate my absolute value. So I'd subtract 3 from both sides. I divide 2 from both sides. And now I break up my inequality into my two parts because I don't have a negative on the other side of the inequality. So my first thing is I'm going to bring down my equation. I'm going to remove my absolute values and change absolutely nothing. And then on the other side, I'm going to bring down my inequality. I'm going to flip the sign of the number. I'm going to flip the sign of the inequality. And notice how I'm not flipping anything on the left side of the equation during that flip. It's still x minus 4. So really when I'm talking about that flip, I'm talking about the inequality sign, symbol, and then the number on the opposite side of the absolute value. And I just go ahead and solve. I add 4 to both sides. I get x is greater than 5, and x is less than, or x is less than 3. I could draw a graph if I really wanted to, but what that breaks down to, as you may have guessed, it's outside. So it's all of the numbers less than 3, all of the numbers greater than 5, so it's everything that's not in between 3 and 5. So to write that in interval notation, I would write negative infinity up to 3, parentheses on 3 because it's just less than, union, parentheses 5, all the way up to infinity. So yeah, it's good to kind of fall into the actual understanding the process and understanding what's going on. But it is also nice to know that if you get an absolute value and you've solved for it, it's by itself, and you know what type it is, you know what you should get for an answer. You know how your interval notation should look like. And no, I don't expect you to always graph the inequalities. If you want to go straight to the interval notation, that's perfectly fine. But if you don't feel comfortable with where these interval notations are coming from, go ahead and graph it. It's a very helpful visual cue. In fact, I think it's a very good idea for you to right now graph what x greater than 5, x less than 3 looks like, and hopefully you'll see where I get that interval notation from. Well, now we're on to that special case, and you may have guessed it. At this point, we're going to get an absolute value, and we're going to get a negative number on the other side. I subtracted 5 from both sides. I have x minus 4 is greater than negative 4. Well, the absolute value of x minus 4. Well, special case. Alarms going off in your head. You see absolute value, you see a number on the other side that is negative. Now, you might think, well, the last two cases that we saw, we had no solution. That seems pretty logical. Now, bear with me because this explanation is a little bit tricky and it's hard to grasp, and so you might have to kind of marinate on what I'm talking about, but I'm going to give it my best shot. So in this case, now I'm talking about an absolute value, and yes, it's x minus 4, but really let's not get bogged down with that. Let's just think at the absolute value of something. So the question we're going to ask ourselves now is, what number's absolute value or has a distance that is something that is bigger than negative 4? So what thing has a distance that is greater than a negative number? Well, if we think about it, if you took one step outside of your house, you traveled a positive distance. So any amount of travel would get you a positive distance. And so with that same logic, any x value that you plug into the left side of that equation will work. It will give you something that is bigger than negative 4. It's something bigger than even negative 1. So this answer is actually the opposite of no solution. It's everything. Everything works. And so the interval notation for all real numbers is negative infinity to infinity. Or if you want to use the fancy symbol, I don't think I wrote it in this slide, but that capital R with 2 dashes, that's also all real numbers. I would accept that in this case.